Hi, my name is Jens and welcome to my presentation on rethinking GraphQL operations as a server-side language to build backends for frontends. I'm the founder of Wundergraph and happy to guide you through the next 30 minutes. So for me personally, GraphQL is a tool that has its place. It has its pros and cons. For me, it's not a religion. And we should always consider technology as a problem solver and not get into like too many discussions about should you use GraphQL or should you use REST or anything. And before we dive into the topic, I'd like to go through some of the like many statements I see in the community, just to get a feeling of where in the hype cycle we currently are. So one of the most famous statement you see is that GraphQL is better than REST. I think both have their place. Depending on use case, you should always consider when to use what and not just use one over the other, because it really depends on your case. And for example, GraphQL could be a very good tool for GitHub, which offers a public API to many consumers that they don't know. But if you know your consumers extremely well and the number of consumers, for example, is one, it's yourself, then you should really think about if you actually need a GraphQL API. The next one is GraphQL solves under and overfetching, which is true and also true for a REST API that has a query parameter to define which fields I want to have. So is that really something unique to GraphQL? Questionable. The next one is GraphQL is type safe. And yeah, that's also true. And I quite like it. It's very good. On the other hand, gRPC is type safe too. And what about open API specifications? Those all go in the same direction, don't they? The next one is, so with all this complexity that GraphQL brings, we have persistent queries and they seem to solve all your security and performance problems. We will be talking a lot more about persistent queries later, but let me just say that this statement is kind of true, but also comes with a lot of overhead and a lot of work you have to put in to organize persisting your queries and getting all that right. The next one is authorization in GraphQL is hard, and I think it actually is. With a REST API, for example, it's very clear to say, oh, okay, I require those specific claims or something, like a role for a specific endpoint. And with GraphQL, this is harder to distinguish. You have to put some logic into user resolvers, or you could use like schema directives. So there's many ways to tackle that, but it's definitely not simple. Another one is you cannot cache GraphQL queries. And well, you can definitely. And I think the best answer on this statement we have from last year's GraphQL Summit, that is from Marc-André, who said when you have a very dynamic API, it's harder to cache versus a very specific API, like for example a RPC API, which is easier to cache. And we will come back later in the talk to exactly this point and we'll see if it actually holds true. The next one is you just need a GraphQL database or ORM and you're almost done. So I see a lot of hype about tools like, for example, Hasura, where you take your Postgres database, you turn that into GraphQL and all your problems are gone. And so from my reality, there's usually not just a Postgres database, there's different services, you have to combine them together, and then you have different systems that provide authentication methods. And so there's a lot more things to be done than just spinning up a database plus an ORM. So I quite like tools like Hasura or GraphQL or you name it. They can help in specific use cases, but they are not the holy grail to solve all your problems. The next one is GraphQL SelfDocumenting. We have the GraphQL schema. It gives you a lot of information on your types and fields. That's very useful. And you could also add some descriptions that could also help. But the question is, how is that distinguishable from, for example, a Protoro that documents a gRPC API or an Open API spec that documents a REST API? And by the way, OAS files or Open API spec also comes with functionalities to define what a valid value for a specific field or argument is. So it's actually, in that regard, a lot more powerful than GraphQL. And then there's also the transport layer, which the schema doesn't tell you anything about. Then you might need to authenticate yourself. You need to have some authorization rules applied. And all that information is not available through the GraphQL schema. So yes, GraphQL is kind of self-documenting, but also lacking a lot of information that you actually need as a developer to get going. And the final one is federation solves all your problems. So also on this topic, I see a lot of hype around federation and how people want to adopt that. And I think, so there's a very popular book from Martin Kleppmann on distributed systems. And I think distributed systems also always add a lot of complexity to your system. So if you split up one single monolith into multiple services and you turn a function call into a network call, there's a lot of things that could go wrong, and you should always consider the trade-offs, that what you actually get from something like federation and what are the costs. You need to deploy more services, you have those network calls fail, etc., etc. So just consider all the pros and cons before deciding for a technology, and not just choose technology because it's currently something that is super hot. So with all this discussion about pros and cons, the question arises, if we go through the hype cycle of GraphQL, what is actually a very good use case for GraphQL? What is something that GraphQL is very, very good at? And so from my point of view, I think where GraphQL actually shines is when you want to query data from different services and you somehow make it available that you get the data through a single GraphQL query. So when you can write a single GraphQL query to traverse different domain models from different services, I think that's very powerful. Another one is if you run a public API like GitHub, for example, they are not able to know all the use cases of their clients. So for them, it's very, very useful to offer a GraphQL API, because they don't have to adjust their REST API like all the time, because developers can pick from the GraphQL API whatever they need. The thing is, most of us don't build public APIs. Most of us build APIs for ourselves, for people that belong to our team or our organization, and we can usually talk to them. And even if you build partner APIs for partners, you're also able to talk to those partners, and they will not go into the millions. So it's always something to consider. Do you really benefit from using this technology? And if you think the answer is yes, then you should also take into consideration the trade-offs, because running a GraphQL API is not extremely simple. It comes at a cost. You have to secure it. You have to make sure it runs performant, etc., etc. And so with that, I want to head over to discussion. Would you open up your MySQL database to the front end? And the answer usually is no. So who would ever want to do that? I guess nobody. And the thing is, in case you run a GraphQL database and open that up to your front end, actually a GraphQL database and a MySQL, a GraphQL API and a MySQL database, it's actually kind of very, very similar in that regard, because it lets you do a lot of things that you might actually not want the user to be doing. So take into consideration the efforts it takes to protect a GraphQL API, and not just apply it to any problem you see. Okay. So with that, I want to head over to the next section where we talk about actually good use cases for GraphQL, at least from my point of view. And so to make this a bit more illustrative, I have a example scenario. So this is the GraphQL in-space conference. So let's say you're a freelancer and you're asked by acme.com to build a landing page for a rocket launch. So we will head over to the demo in a few minutes. And what you will see is a website where we have it's a landing page for a rocket launch. You can see the tasks that we need to do in order to launch the rocket. Users can log into that site and comment. Then we have the rocket control API. That's a REST API to actually control the rocket. We have the astronaut editorial. So we have some information like a picture, description, etc. about the astronaut that will sit in the rocket. And then the rocket control API, it tells us the country code of our of the rocket. So it tells us the country code above which country the rocket currently is, and we can then take the countries API from Trailblades and turn that into some country information with country and capital, so that we actually know, okay, the rocket is currently at that altitude and speed, and it's above this and that country. Okay, so this is kind of what we want to build, and we want to see how we can benefit in this scenario from using GraphQL. So some of the considerations we want to make here is we want to authenticate our users and we want to apply authorization. So we want to make sure that you can only post a comment or add a task if you're authenticated, and you should only be seeing your own personal tasks, of course. Then for the editorial part, we want to add caching. So it will not change that often, so we can actually cache that. So we want to cache the API results. And for the rocket launch, we want to have real-time updates. So we have, behind the scenes, we have a REST API that gives us the current altitude, speed, and country code above which the rocket is. And we want to take this REST API and turn it into a real-time subscription. And then finally, what we want to think about is how we integrate all those services. So if you go back to this slide, so we have tasks, comments, rocket control, astronaut editorial, and countries. So that's 1, 2, 3, 4, 5 services. Two of which or 3 of which cloud services. So we have /dgraph, we have Founder-DB, we have GraphCMS. We want to integrate them all into one unified API layer. And the question is, where do we do that? Like, do we do this in the client? Do we build a backend for frontend? Do we build a custom middleware? Where do we put the API keys, etc., etc.? We need to consider how we build the user experience. So there's lots of ways how to do that. And finally, we want everything to be performant, secure, etc., of course. So the question is, how can we tackle that? And ideally, we will be able to abstract away most of those problems. So the integration part, so integrating all those APIs, ideally, we could just configure it. So we don't have to do anything. We could just configure it. the middleware for this specific use case, we want to build that without coding, okay? The authentication, authorization, and caching layer, this is always also something that ideally we can just configure it and the problem goes away. And finally, based on the API layer, so the middleware layer that we generate, we actually want to have a code generator that takes this configured or this specified API, turns that into a very smart client that knows exactly how the backend works and can talk to it very easily. So with that, ideally, you as a developer, as this freelancer, you can fully focus on making this a very, very good user experience. You focus on your business and you don't have to write like so much glue code, okay? So the whole authentication, authorization, caching, I want my type safe client, all those problems, ideally you can just abstract them away. And this was the motivation for me to start building Wundergraph, because I personally encountered those problems over and over again, and I wanted to build a solution that just abstracts them away from me. So part of the puzzle in this case is we're heavily using persisted queries, and I kind of see persisted queries as a way of defining JSON RPC. So you take a query, you store it on the server, and it kind of becomes an endpoint. So what are the origins of persisted queries? So if you look at this post from Lee Byron on Twitter, for example, it's from 2013. He said that Facebook used persisted queries in back in 2013 just to make things more secure and more performant. There are, I also heard someone at Medium say they use that too, and I guess there's many more who use persisted queries. You have different flavors, so not everything that is named persisted queries is the same thing. Some name it, for example, query whitelisting. And then there's a very specific group of persisted queries, and that is compiled queries, and that is what we use at Wundergraph. So by compiled query, what I mean is I'm not just taking a query, storing it on the server and then executing it later. Compiled queries instead mean at compile time, you take the query, you lex it, you parse it, you normalize it, which means you clean it up from white space and everything. Then you do your validation, and then you compile the query into a executable tree. And that executable tree, you will store it into a hash map, and it's very efficient to execute that executable tree. So at runtime, what we do is, so we take this query, we store it, we create an endpoint for it on the fly. So there's no build time step, or you don't have to deploy anything to do that. It's simply storing a query, and then everything happens behind the scenes. And at runtime, we take the executable tree out of the hash map and we simply execute that, and it's extremely efficient. So at runtime, the only thing we need to apply is we apply the authorization rules, so who can see what. We take your job, we validate that, we inject that into the query or the executable tree, and then we might add a caching middleware here and there to cache some results, and that's basically it. Okay. So from my point of view, GraphQL is an amazing technology if we keep it on the server. So whenever you can actually benefit from this approach a lot, because it kind of gives you the same flexibility as you know it from GraphQL, but without all those performance and security problems. Okay. So to the benefits of that, we significantly reduce the attack surface, because to the outside world there is no GraphQL server. And another aspect of that is because the GraphQL queries sit on the server and never leave it, they don't get to the client, we can actually move authorization rules or authorization directives or rules from the resolvers into the queries, which means, for example, if you consider that normally you have, for example, auth directives which you apply to the schema. It kind of limits the use cases that you could have for your schema. If you move this logic to the query, it gives you a lot more flexibility on how you could use your services. And then finally, all this completely decouples the implementation from the backend and the API consumer. So here's an example which we can see. So this is our debugger. So on the top, you can see a JSON that is actually the content of a JWT. So we have two claims, email and sub. And the query reviews, this is a persisted query. So by defining the query reviews, what we actually do is we create an endpoint, and that endpoint is named reviews. And what we also do is we take the email variable, and the user cannot supply that variable. What we do instead is we take the claim email from your JWT, so you have to be authenticated, and we take that and override whatever you supply as email. So it doesn't even matter if you supply something. We will always take the email from your JWT, and if your JWT doesn't have an email, then you will not be eligible to execute that query. So that is one. So this means we have authorization embedded into this query because you only get the reviews that are tied to your identity, while the upstream API, so the reviews API, that's in this case it's coming from GraphCMS, it has no concept of authorization. We added that on top. The next one is we have this cache directive. So we add cache control headers, max age 120, plus we add the JWT.sub. So the sub from the JWT, we add it to the internal cache key so that each individual user gets their own cache key. And something to say about the cache directive. So because this reviews query through the compile time step becomes a get endpoint, we can add those cache control headers, and this means that you could put a CDN in front that can totally cache those queries, or your browser could do the same thing. So it's very easy to cache, no problems. And with that, I would like to head over to a live demo. So let me just prepare my environment. So we have a bunch more minutes. That's amazing. Okay. So here's our browser. Let me just restart our environment. So we have the Wunder node, which needs to be up and running. So here's our console, which we will see in a minute. And this is the actual React application. So here we see the astronaut part, that's the editorial. All this content is coming from GraphCMS. So you can see here, this is the GraphCMS interface where we created that content. Then we have the tasks. In order to use that, we need to be logged in. So I just make sure I'm not logged into GitHub. So I log out here. And then I click the login button. I sign in. We get redirected. You see I have all these tasks. So astronaut is already in the rocket. That's amazing. Then, for example, I could ignite, and then we could proceed to the launch experience. These tasks, they are coming from dgraph, so /dgraph, that's their cloud service. It's coming from there. And then you have the comments. Those are coming from FaunaDB. So we've also added FaunaDB to the stack. So this is the comment. So hello from GraphQL in space. So we could add that comment, see it in our list here. Awesome, that works. And now we go over to the real-time part. So behind the scenes, we have the REST API. The REST API tells us the altitude and height of the rocket and the country code that the rocket is currently above. And then we have the Trailblades countries API. I'm running it locally. And we take this subscription and join it with the countries API so that we always know the country above which the rocket currently is. So let's head over to rocket status. You see currently no speed. So we hit the launch button. You see it speeds up, altitude is climbing, and it's starting in United States, of course. And then after a bunch of seconds, so this is all scripted, it's just a demo, of course. No real rocket flying. So it's then moving to Canada, Antarctica, speeding up, then Ireland, United Kingdom, capital is London, then Netherlands, and finally it gets some acceleration above Germany, and that's basically the whole story. So if we look at the configuration, so this is our WunderGraph console, which is we're currently in public beta. So if you're interested, go to wundergraph.com. Just log into the console. It's free of use. Try it out and give us feedback how we can improve that. So we have the concept of data sources. So I added all those data sources here. So I have my editorial, the comments, the to-dos, the countries, and all that. Houston, that's our REST API. So we can take REST APIs, turn that into GraphQL on the fly. And then we have GraphQL in space. This is a compose API, so I can say add new data source. I can then select compose. So I select a bunch of APIs, then merge them together to get like a single unified API on top of all of them. And then the next concept is we have the application. So here we combined all those APIs, and then we can define all the endpoints or the persisted queries or the RPC calls, whatever you call it. So we have add task, all the tasks. We can set the task completed. We can delete tasks if we want. This is the astronaut page where you see we disable auth because we don't need that here, and we apply caching. This is the record ID from GraphStream-S. Here we get all the data, including the image. Then we have all the comments coming from, that was FaunaDB, add a comment to Fauna. And finally the launch API. So post launch, that is the REST API. And then we get a subscription. We don't need auth for that, so it's public. And the rocket status, it comes from the REST API, and then we take the country code and join that against the GraphQL API. So we can have a look into that. So we launch the rocket, and then we got the rocket status, and you see the data is updating. And with all that, so we configure the data sources, we configure the applications, then we configure auth. So I have my auth provider configured here, that is GitHub in this case, and I have created a client. And then the final step is we have a code generator that is WunderGen. It takes all this configuration and generates a provider. So that is our dependency injection container. It generates the hooks, so all the React hooks that you actually want, plus a client. And the client, it contains all the specifications for your whole GraphQL schema across all services. Plus, it's an OpenID Connect client that automatically does all the login. So if you look at our index file, you see this is all generated, this WunderGraph provider. It doesn't take any configuration because we can generate all that. So it's very easy to set up. Also, if you have like a subscription transport, you also don't have to set up anything. It's all batteries included. And now we can go to one example that illustrates how you would actually use that. So here's the comment view. So from the Wundergraph hook, we actually get information if the user is authenticated, and then we can run that operation. So here's our fallback in case the user is not authenticated, and add comment, it's a simple hook. So you see, with that code generation, we can hide all the complexity of how do you log in a user and how do you make all those calls. We hide all that because behind the React hooks. Okay, so that is that from my demo. I hope you enjoyed this talk, and now I am happy to take any questions. Thank you, and see ya.